Hello, everyone. My name is Zhang. I'm a data scientist in Azure ML product team located in Boston, Massachusetts in United States. So our team mainly is to engage with external customers to help them build end-to-end solution on Azure platform. And for our team, we mainly focus on the solution on Azure ML. So in today's session, I'm gonna show you how to build a predictive maintenance solution on Azure ML. So I'll start with introducing Cortana Analytics Suite. As some of you may or may not know, Microsoft just released Cortana Analytics Suite in July. So it is a cloud-based advanced analytics platform, including many different tools and services in Azure. So you can see from the screen that it contains many different components, including, say, on the left-hand side, when the data is input into the cloud, it has different services to handle the data input. For example, the Azure Event Hub, it actually helps to inject different data sources into Azure. And then we also have Azure Data Factory, which helps to manage the jobs or schedule different jobs without manually scheduling. And also after data is injected into cloud, we also have big data stores to help to store the data, for example, Azure Data Lake or Azure SQL Data Warehouse. And also the third column shows advanced analytics, including Azure ML, which we are going to focus today, Azure HD Insight, which is the Microsoft's Azure version of the Hadoop system. Is distributed the cluster to help to those heavy-duty data crunch, data pre-processing tasks. And also for Azure Stream Analytics, it is really good for handling streaming data or the live data streams coming into the system at real time. And then for the fourth column on the right-hand side, that represents the end client, which consumes all these different models or analytic results from the previous stages. So today we are going to focus on Azure Machine Learning, how we can approach a predictive maintenance problem and formulate using an Azure Machine Learning modeling strategies. So here I'm showing the data pipeline of today's talk. So mainly in the center, I'm showing you a typical cross-industry standard process of data mining model. In the middle, the circle represents this whole process. So we should understand that analytics is not just one piece. It actually represents a solution. It's an end-to-end solution from business problem understanding to data preparation, modeling, evaluation to deployment, which means it eventually will produce a solution so that the client application can make usage of. So it's just not a single analytics part. You build a machine learning model or some statistics results. It includes this whole process. So then for today's talk, we are gonna actually include this data preparation, just assuming we already have a well-defined business problem and we understand the data well. And today's talk, we are going to inject the data into Azure ML and prepare the data, including data labeling and feature engineering. And then we will create different types of machine learning models within Azure ML, and then evaluate them, choose the best model, and deploy the trained model as a web service, so that the desktop application consume this web service. And in this data preparation stage, I want to say it can include different steps. It can include data cleansing, which say you want to make sure the data is correct. You want to make sure the data types are consistent with each other. But for today, we are going to mainly focus on data labeling and the feature engineering part. So here is the outline of today's talk. I will first of all introduce the predictive maintenance in general, kind of what is predictive maintenance, why it is important, and why we want to raise this kind of applications. And then I will introduce the actual data we are going to use. It is a set of publicly available data set, so that the advantage of that is you can go ahead to download it from the source so that you can try it by yourself. And then I will introduce how we can build this end-to-end solution using Azure ML, from the data input to data preparation, model building, construction models and evaluation, and then eventually build a web service. So essentially for this Azure ML part, we have built a set of template experiments using Azure ML. And for these template experiments, you can also download from Azure ML Gallery site. So it's very convenient. There is a whole set of documentation available for you to use as well. And then in the end, I will show the demo. We have built a desktop application to actually consume the web service we deployed from Azure ML. And I will show you that demo. So the objective is, by the end of this talk, you are supposed to understand the data science process in general, and you will also get an idea about what is predictive maintenance application and how you can approach the problem using machine learning approach, and essentially how to actually build this kind of model using Azure ML. Although you may not fully get the whole process, but at least the resource available there, so you can go check out the Azure ML and the corresponding predictive maintenance template through Gallery. So first of all, let me just introduce predictive maintenance briefly. So predictive maintenance actually is not a new concept. It has been a concept in reliability-centered maintenance domain for many years. So the concept is, instead of performing time-based preventive maintenance or breakdown maintenance, we want to perform this kind of predictive maintenance, so that we know in advance when some kind of maintenance should schedule ahead of time. So just want to give you an example. We send cars for oil change every 6 months or every couple of thousand miles. So this kind of maintenance is time-based maintenance. But then in order to make sure the machine to work properly all the time, and also reduce the machine downtime, we want to perform predictive maintenance instead. So then why is we want to raise this question again? Because nowadays we are in this Internet of Things era. In many Internet of Things applications, predictive maintenance is one major task for these applications. For example, in industrial Internet of Things applications, we want to maintain machine parts, right? We want to maybe, kind of the main goal is to improve the production or maintenance efficiency. So that the major difference from traditional predictive maintenance is the data we get from these Internet of Things applications are really yearly data streams. There can be multiple data sources coming from various sensors, etc., at real time. And also because of all these big size data, the scope is also changed a little bit. Instead of focusing on the parts level, the lowest level of the machine parts, for example, the bolts, etc., we mainly focus on the component level or machine level. For example, we want to predict when the elevator doors will have a failure, or when an aircraft engine will have some kind of symptoms of fault. So it requires us to actually perform data-driven types of approach instead of model-driven. So for model-driven, it means we know what is the physical formula of the machine functionality. So we kind of have the model first and then feed the data into the model. However, in this data-driven approach, mainly we have a lot of data. So we want to start from data and then to see what kind of insights or results we can infer from the data. It is called data-driven approach. And mainly here we are talking about machine learning models. And also for the tasks, in predictive maintenance in IoT actually covers a lot more wider range of different tasks. Anything actually can improve production or maintenance efficiency can be under this umbrella. So in today's talk, we are going to focus on failure prediction, machine component failure prediction. I'll introduce in details when we talk about details of this problem. So for predictive maintenance, actually can be applied in many different domains. For example, aerospace. If we want to know what is the likelihood of the delay due to mechanical issues, it falls into this kind of application. Another example is when this aircraft component is likely to fail next. So for predictive maintenance also occurs in other domains, for example, utilities, manufacturing, transportation, and logistics, etc. So in terms of machine learning modeling for predictive maintenance, actually we can, so far, actually the most commonly, excuse me, the most commonly applied techniques include binary classification, multi-class classification, regression, and anomaly detection. So for anomaly detection, it mainly works on the real-time data. So it means when the sensor values or data streaming in, we want to check if there is any abnormal behavior in the data. So we know there may be some problem for this machine or for this machine parts. So this is a real-time kind of analysis. And then, however, for today's talk, actually, we are going to focus on prediction. We have collected a lot of historical data, and not only just the real-time data. We have this historical data. We want to build, classification or regression models to predict when an in-service aircraft engine is going to fail. So essentially, we are going to actually focus on these three different problems. First, for binary classification, we want to ask the question, and if in this time period, if this aircraft engine is going to fail or not. For binary classification, it answers a yes-no question. So essentially, it's a two-category classification problem. And then for multi-class classification, we want to ask the question, say, whether this aircraft engine is going to fail within these different ranges of future time period. So essentially, we define the future time period into several periods to answer the question whether the failure will occur in one of these time ranges. And then we also formulate the problem into a regression model. So we want to answer the question, so what is the remaining useful life for a specific aircraft engine? For the remaining useful life is, amount of time before the next failure. So here, the amount of time is really depending on different use case. So here it can be actual time, say how many days it can run before the next failure, or say how many more miles a car can run before the next failure, or how many more transactions this machine can have before the next failure. So this kind of amount of time here is depending on different applications. So let me just introduce the data we are going to use. So the link shown on the slides represent the data source. So we got this data from this NASA site about turbofan engine degradation simulation data set. It contains 3 data sets. We use actually in this project is mainly aircraft engine run to failure data. I'll show a snapshot of data in this slide. So it shows us what the data looks like. So you can see from the top part, it shows the sample training data. It shows us the first column represent the aircraft engine ID. It contains 100 different aircraft engines. So now it's showing, 1, 2, it's showing 2 aircraft engines, but essentially there are 100 different aircraft engines. And then for the cycle, you can imagine it represents flight. So each cycle represents a flight from, say, one city to another. So then for each different cycles, it contains 3 settings and 21 sensor information. So you can consider it this way: for each flight, it has gathered an aggregated data for different settings and 21 different sensors. We actually don't know what these sensors mean because it's only just labeled as S1 through S21. So you can just consider these sensors related to aircraft engine performance. Okay, because it is run to failure data, we can consider that the last cycle of each aircraft engine is where this engine fails. So all of these engines fails on the last cycle showed in the training data. For example, aircraft engine 1, it fails at cycle 192. And for the second engine, it fails at 287 cycles. So we know these information. I will show how do I actually label the data and how do I generate the features. So data labeling is a very important stage for preparing the training data for a machine learning task. We need to have the labels in order to train a supervised machine learning model. So first of all, we want to train the machines to say, hey, I know these different data instances. We also know the label of them. So we train the machine this way. And then when we have the testing data, which contains only features, not labels, then the machine will tell us what label that testing instance belongs to. So that's kind of a logic of why we want to label the data. So here, actually, we are showing, we are creating 3 additional columns called RUL, which represent remaining useful life. That's the class attribute for a regression model. And then we have label 1, which is a class attribute for binary classification, and then label 2 is for multi-class classification. So let's see how we actually created this remaining useful life column. So as said earlier, we know each aircraft engine actually runs from the initial cycle through a certain number of cycles. For example, this first engine actually runs through cycle 192 and fails at that cycle. So we can just take that number subtracted by the current cycle of each row so that we got a remaining useful life. It's very simple subtraction. 191 equals to this number subtracted by the current cycle 1 to get that number, so that we can fill out this remaining useful life column. And then for a classification problem, we have to define the window size beforehand. So this is a manual process. We have to decide what's the window size we want to have for this case. From the business point of view, say if we want to predict failure in a 15 cycles range or 30 cycles range, we can make that decision to see what window size we want to have. For example, here we define the window size for binary classification to be 30. So when you look at the label 1, you can see any cycles within the 30 cycle range, we label them as 1, which means it indicates a failure. And then any cycles beyond this range, we label them as 0, which means a non-failure event. So instead of having just labeled the last cycle, this failing cycle as failure events, we also label the previous cycles as failure as well. Just assuming it's the failure is a degradation process. So the same logic applies for multi-class classification as well. Instead of have 2 labels, we have 3 labels. So then after we have labeled data, we want to perform feature engineering. So normally when we take the raw data, it already contains many useful features there. So the features actually kind of tells us what's the pattern behind the data so we can perform classification. So the process of creating additional features is that we want to actually provide better or additional predictive power to the learning algorithm. So in this project, we actually created a couple aggregate feature. For example, the rolling average of the sensor values from the most recent cycles. And also we captured the standard deviation of the sensor value changes in the most recent cycles. Here we have to define this W. What's the W we want to be? We define it as 5 cycles. We actually get the most 5 recent cycles and get rolling average and the rolling standard deviations. And you can also, actually create other meaningful features. So here, after we perform data labeling and feature engineering, eventually this is what we got of the training data. So on the left-hand side, it shows it's the same actually as we showed for the sample training data. And then we created 40 plus engineered features. And also we have created 3 class attributes for different machine learning models, right? So essentially this whole thing represents the training data that feed into the machine learning model. So, and also for these features, there are also other potential features you can create. For example, you can create the change from the initial value, or the velocity of the change, frequency count over a predefined threshold, and so on and so forth. So we have showed how to prepare the data. And now let me just switch gear a little bit. I will briefly introduce Azure Machine Learning. So for those of you who don't know, Microsoft Azure Machine Learning is a cloud-based machine learning platform. It has interface like the one showing on the screen. It's, after you log in the account, using that URL showing on the slide, and you can see this kind of interface. So there are 2 types of price tiers. There is a free tier and a standard tier. For the free tier, actually it's totally free. You can just try it out by yourself. But the only limitation is you can only use Azure ML itself. So you cannot use other Azure services. For a standard tier, when you sign on, you automatically get $200 free credit to use in Azure platform, so that you can use Azure ML together with other Azure services as well. It means you can, for example, you can import data from Azure Blob Storage. You can import the data from Azure SQL database. That means how you kind of connect Azure ML to other services within Azure. So, so some advantage of these platform includes follows. It is completely managed for you. It's a cloud-based platform. It's completely managed for you. You do not need to purchase additional hardware or software. The only thing you need is a browser and internet access. So that's all. So you do not need to install additional software. And also it contains for these different machine learning algorithms. Many of them are got from other Microsoft products, for example, Bing or Xbox. So there are pretty solid set of algorithms. And also it has actually the extension to support R or Python. So you actually can include R or Python code into the experiments. And also you can work with anyone in the world by using the workspace sharing function. When you share the workspace with someone else, so you can very freely collaborate with other people. And also, the major, I think the key differentiator of Azure ML lies in that it provides you an opportunity to build an end-to-end solution. So it's very easy for a business actually to store the data on the cloud and also build a data analytics solution, and then actually integrate back into their business. So it's very easy. And then for the data scientist, actually, you can build your machine learning models and also, publish this web service as a API, and so that you can sell this API in Azure Marketplace. So you can even make money of it for data scientists. So just now I have showed the Azure ML interface briefly, what the experiment looks like. So now let me just show you, the template experiments for predict maintenance. So we have developed this set of template experiments so that it can be easier for data scientists to learn how these different data preparation steps or model construction steps are, so they can easily take this into their own problem. So we mainly split this whole process into 3 steps. And the first step represents the data preparation step. It means you get the data in and you perform data preparation, feature engineering, etc., and fully prepare the training data. And then for the second stage, actually you build the machine learning model and evaluate them. The third step represents the process of creating scoring experiment or to deploy a web service. So remember that we have created 3 class attributes, 3 columns. So that's why we just need one set of training data. And for these 3 different models, we just use different class attributes to build these different models. So this slide shows you a screenshot of the first experiment, what the data preparation step looks like. It has the data input on the top, and also it shows you what steps for data labeling, feature engineering, and so on and so forth. So now let's take a look at the second step. Because of the time limit, I will only show you what the regression model looks like. So this slide actually shows you a snapshot of a regression model. And on the top, it shows you how the data is read in, and several modules here to process the data. And in the bottom, you can see there are 3 different branches. Mainly, it shows you 3 different machine learning algorithms are comparing here. So you want to compare these 4 different machine learning algorithms and pick the best one. So essentially, we pick the boosted decision tree, and in the end, you can review what's the results. It looks like, what's the error rate, so you can pick the best model. So now I'm showing you this scoring experiment. So what's the difference between scoring experiment and a training experiment? It is because when you create this scoring experiment, you will deploy the web service from it. So mainly it contains a web service input, the red squares showing on the screen, and the web service output. So it mainly defines what's the input data schema and output data schema, so that when you create your web service, it has to be compliant to these same data schemas. So after you finish running this scoring experiment, you will see on the bottom of your Azure ML interface, it shows you set up the web service, and then you can very easily deploy the web service within Azure ML. So then you will see this kind of screen. This is how web service looks like. It shows you different information, including what is API key and what other information are, for example, this request response. These are the documentations included for this web service. If we click this link, actually it's going to show us a documentation including a lot of information. And here I got a screenshot for this sample code. It provides you sample code for C#, Python, and R. So it's very convenient for you to just pick the language you are familiar with and copy the sample code and insert very limited several pieces of information needed into the sample code, and then make it work. So let me just quickly show you the demo. So the demo I want to show is to get the remaining useful life back from the regression model we deployed within Azure ML. So actually, this is the interface. It's just a desktop application, you can see. So here, actually, we have previously recorded information for testing data. So it's also about aircraft engines. But instead of having a run to failure, it runs from the initial cycle through current cycle. For example, this 49 represents this aircraft engine 2 has run through current cycle 49. So if we want to know how many more cycles it can run before it fails, we can click them and to get the remaining useful life back. For example, let's just choose engine 5. So currently it has been running through cycle 98. So when we click predict, actually the request is sent back to the web service deployed from the Azure ML. So now it shows us, right now the last point shows us the remaining useful life is about 110 or so. You should see the last point. 98 represent the x-axis represent the current cycle. The y-axis represent the remaining useful cycles. So the last data point actually represent the remaining useful life for this engine 5. So all these different points in the course on the line, it represents if we only take the initial value through a specific current cycle, what's the remaining useful life looks like. So mainly it just shows us, how the client application make a call to the backend web service. So far, let me just summarize. So far for this demo, we showed that when we save the data into Azure Blob Storage, and Azure ML can read this data from the Azure Blob Storage, and then performing data preparation, model construction, model comparison, so on and so forth. And essentially, it deploys a web service from within Azure ML. And then this desktop application consumes this web service from outside of the cloud. So of course, in the real scenario, you can have different client applications. Either it can be a mobile application or web app. So, but the idea is the same. Let's just revisit this Cortana Analytics suite. So today we actually focus on how we actually can build an web service within Azure ML. In the real scenario, actually, we probably will need to have more complex platform. For example, for a predictive maintenance case, if the streaming data coming in, we probably want to take advantage of this Azure streaming analytics so that we can perform real-time analytics. And then we can save some of these data into Azure Blob Storage and then import them into Azure Machine Learning Studio to build models and perform predictive analytics. And also, we probably want to use Azure Data Factory to schedule all these different jobs without manual interaction, with the system. So I really encourage you to try out Azure ML, and there is a bunch of sample experiments available in Azure ML Gallery. So it can be different use case. You can find one you are interested in and just open it in your workspace. Then the experiment will be automatically copied into your workspace, and then you can start manipulate it. And in order to find out the predict maintenance use case I just showed, you can just search for predict maintenance, and you will see there are a bunch of experiments actually coming out. And you have to, spot this picture. So this is the one, for this template. There are totally 7 different experiments. So you can just pick, one of them. There is a full documentation available there. And also, you may want to check out Cortana Analytics Suite as well. So I think I will stop here, and I will take any questions you may have.
Thank you very much for the presentation. And now we are coming to questions.
Sure.
So, yeah.
Hello, Jan. Thank you very much for the presentation. Can you hear us?
Yes, I can hear.
Okay, great. Can you please show us your desktop application again? I have a question about the chart.
Sure.
Yeah, thank you. And here you said that this last point was the actual prediction, right?
Actually, every point along this line represents a prediction. So instead of one web service call, actually it's a bunch of web service calls. So each dot here represents a prediction results. But the last point actually represents when this engine is at cycle 98, this point, what's the remaining useful life?
Yeah. Actually, I thought that
Yeah.
it was only the last one, but yeah, if you say that every point is a prediction, that explains everything. And if you select a different engine in your Dropbox drop-down list, then it will show us different picture, right?
Yes. So if we choose a different engine, for example, this one is sending the request back, and it will show us what's the remaining useful life for this engine number 11 during the course of this cycles.
And what was the winning regression model out of those four?
Excuse me? What's your question again?
What was the best regression model that you used here?
Sure. So the model behind this is boosted decision tree regression.
Thank you.
Okay, any more questions?
Jan, hello. Could you say maybe do Microsoft has currently implemented predictive maintenance scenario in real case world? What do you know about?
Hello? Can you repeat your question again,
Yeah,
please?
so the question was, can you share some like examples in production where this technique is used?
Oh, sure. So actually, so far we have engaged with many customers to work on different different predict maintenance use cases. Mainly I can only cover the high level, not a specific use case, because some of them cannot be discussed publicly. Just for example, to predict in general, say elevator door failures, or to predict an ATM machine when the ATM machine dispense notes, what's the risk of failure for the next 50 nodes, for example. So we are engaged with this kind of scenarios for predicting maintenance. And also I would say every case is different. So we really need to understand the business problem and fully get the relevant data. So this is very important. Sometimes in order to get the relevant data, it takes a lot of time to get really the high quality data. And also, if we have domain knowledge, if we can create highly relevant features through feature engineering, it's highly recommended in this whole data science process in order to get the accurate prediction.
Okay, another question?
Thank you, Jan. My name is Serge. Currently, we are trying to build an application based on this machine learning studio, which analyzes the activity of a user, and we are keeping the movement of a mouse with some parameters, and analyze it in Microsoft Azure Machine Learning Studio. My question is, could we use some tool of Azure to get online or real-time analytics like movement of mouse or other behavioral things which user make on other websites not connected with Azure, any websites? Thanks.
So do you mean you want to see kind of real-time data, kind of analyze real-time data, but without using Azure? Is that your question?
My question is, could we use some tool of Microsoft to get real-time data from websites which are not based on Azure? Any websites, or mobile applications. If they are ready to embed like some code of Microsoft tool, like JavaScript code, like Analytica, like Google makes with Google Analytics.
Sure. So you mainly are focusing on, say, the data acquisition stage, whether Microsoft offer any tools to help to get this kind of data from some websites, any websites you are interested in, those kind of data. So right now, it's not on the top of my head. But I can, I got your question, and I can give a follow-up, after this, after I find out if any tools are available. So.
Okay, so we'll come back to this question later, and we've got another one.
All right, sounds good.
Hi, first of all, I want to thank you about the great presentation. The model, the data processing chain you have built with Microsoft Azure is really impressive, as is the fact that it can be turned into a data service. And my question is the following. Can the code behind the data service somehow be exported so that it can be run independently from Microsoft Azure infrastructure, for example, as a C# code or something?
No, it cannot. So for the model trained within Azure ML, so it's always sit in the cloud environment. You cannot export the trained model, for example, out from the cloud environment into your local. It's not available.
One comment, I will comment only for Revolution Analytics and switch to Russian. Коллеги, просто хотел дать один коммент. В принципе, действительно, если кто знает или не знает, весной Microsoft купила Revolution Analytics, да, компанию. Это огромный такой контрибьютор в сообщество R. Вот, и там, соответственно, есть R Open, R Enterprise, то есть студия. Все, что вы можете, опять же, вы можете работать с этим на земле, кто боится облака, да, к примеру. Это я сейчас, может быть, там не конкретно на ваш вопрос отвечаю, да, но, в принципе, вы можете работать с этим на земле, да, и впоследствии, да, там в нашем родмапе это будет интегрировано, там, виртуальные машины уже в облаке. Ну, если кто знает про Revolution Analytics. Конкретно из Azure ML нет.
Я тоже хочу добавить, just commenting a little bit on the last question. Ряд механизмов data майнинга присутствует в Microsoft SQL сервере. То есть те механизмы, которые были описаны здесь, действительно нельзя на данный момент как готовую тренированную модель экспортировать и использовать на земле. Но ряд механизмов по работе с данными есть в Microsoft SQL сервере. Okay, so do we have any other questions? Okay, no, we don't. So, Jan, would like on behalf of the audience to thank you for the great presentation, and we wish you the great day.
All right, thank you so much. Thanks for attending.